Welcome to Brain Vision.
What is the pressure inside a 38.0 litre container holding 105 kilograms of argon gas at 20 degrees Celsius? Right, okay, so we're going to begin from two equations. So ideal gas law, P pressure times volume is equal to N, number of moles, gas constant, which is 8.31, and temperature, so PV equals nRT. And we're going to call that equation 1. And our other equation relates the number of moles to mass. So mass is equal to number of moles times the standard atomic weight of the material. Because we want to find pressure, pressure is our unknown. We're going to make pressure, we're going to call this equation 2, and we're going to make pressure the subject of the equation, and we're also going to substitute in equation 2 into equation 1. So N equals M over AR, and we're going to substitute out N with M over AR here. And doing that, we get pressure is equal to M, mass, times the gas constant, times the temperature, divided by volume, times the gas constant. And I like to stick to standard international units because that means that I don't make mistakes when I'm putting this all through a calculator. So the mass is given as M in this case is equal to 1.05 times 10 to the 5 grams. R is equal to 8.31, and our units in this case are given by joules per Kelvin per mole. Temperature is at 20 degrees, so in terms of Kelvin, that's equal to 290, so 273, which is absolute zero, which is 0 degrees Celsius, plus 20, so 293 Kelvin. And our volume is given by so we're going to give this in terms of meters cubed because that's a standard international unit, is in meters, is equal to, so there's 1,000 liters is 1 meter cubed, so that is equal to is equal to 3.8 times 10 to the minus 2, 3.8 times 10 to the minus 2. The standard atomic weight that I think they're using in this question. So the standard atomic weight of general argon is given normally by 39.88, but in this question I believe they're using 40. Otherwise you get a slightly different answer to the one they set out. So it's 40, and the units of this, so this should be meters cubed, and the units here are grams per mole. Or I should rewrite that as grams g mole minus 1. Right, so substituting in, so this is the atomic weight, AR is the atomic weight, but AR is also the, so this should be A subscript R, whereas the symbol for argon is A little r. It's a bit hard to show here, but they are slightly different symbols. So not to be confused, this is the atomic weight of argon is 40 grams per mole. So substituting this all in here, so we've got our 5 numbers here, substituting them into this equation here, we get the pressure is equal to 1.68 times 10 to the 8 pascals. So to get from pascals to atmosphere, so the answer, for some odd reason, these questions seem to have a love with giving answers in non-SI units. So to get from pascals to atmosphere, so we have that 1 atm is equal to 1.013 times 10 to the 5 pascals. So dividing through that answer there by 1.03 times 10 to the 5, we get the pressure is equal to 1.668 atmospheres.